that working? Okay, great. Hi, everyone. So yes, I'm Justin from Boson Protocol. So Boson Protocol is decentralized infrastructure for trading tokenized things. So we're going to talk you through some of our project and also some of the kind of tech that we're using behind that. So first, a bit about the core founding team. So I used to run a company called Priority Pass, and we grew that business from 50 million to $1 billion revenue as essentially a digital voucher marketplace. I've also done a number of architected a number of crypto venture joint ventures with the likes of dexFreight, MakerDAO, and Centrifuge. My tech co-founder Gregor, was previously a lead engineer with the Bank of Slovenia and has also taught master's courses in blockchain programming and architecture as well. We've got a very esteemed list of advisors, including Dr. Zeynep, who's hiding over there. Also, Trent McConaughey from Ocean are the owner of our VC. We just came off of the Outlier Ventures Basecamp project, which, if there's any startups here, is an amazing accelerator for blockchain projects. And then two very strong legal and governance advisors as well. So the genesis really of our concept started quite a few years ago when I started working for a company which some of you may know called Priority Pass. And essentially Priority Pass aggregated lounge visits and then offered those to customers in a physical form as paper and plastic vouchers. So nothing amazing there. And this was, roughly about a $50 million per annum business. And then with the rise of sort of digital and mobile business models, lots of businesses were looking for the same things, that we all want, products and services, but for them to be available in a digitally native way, a way that could be transmitted and could be consumed by mobile apps. And so I took this idea to create digital voucher tokens. So these sort of digital voucher tokens were run on a centralized database, and we expanded the product range beyond just lounges to, within this travel domain, for want of a better word, tokenizing, but using a Web 2 centralized databases, tokenizing products and services. And we also used a platform business model, which at the time was pretty cutting edge. Well, that turned out to be a pretty good idea. That business grew from 50 million to $1 billion revenue per annum, become the global market leader in that space, servicing literally thousands of corporate customers and many millions of consumers. But the problems with that system and platforms in general are manifold. I mean, the platforms have what's known as this kind of extraction imperative, that a centrally owned company has shareholders have a fiduciary responsibility to extract maximum profit from the network, and that was something I was reasonably good at. And yeah, we were able to use our market power to increase costs, but also any platform, its job also is to lock out competitors and lock in customers. And so these are kind of known as some of these endemic problems of platforms. But then operationally, there are also some challenges. So, using a centralized ledger, in fact, multiple centralized ledgers for each company, where you have payment and the actual transaction is separate. So, you've got all of these different ledgers between your companies, between your suppliers. The actual, the record of the transaction is then set separate to a reconciliation and payment. All of these aspects add kind of costs and friction. Also, the fact that between our products and competitors' products, or just any other products, there wasn't interoperability. So an end, like one of our corporate customers couldn't easily recombine some lounge products, some insurance products, some because they all had a different standard. All of these things were problems for consumers and customers. So the next idea that I had was, what if we were to use blockchain technology to enable a similar system to create a universal standard for representing product services, let's generalize that to things, as non-fungible voucher tokens. And so that really is the solution for Boson. And that gives us some different properties operationally. So the transaction itself and the digitization of the product and the value exchange is contained within the same is contained within the same transaction, which means all of that reconciliation goes away. But also we have a neutral protocol, which is quite different to having a centrally owned platform. And we'll get into some of the benefits of that. The third aspect as well is that the Boson Protocol vouchers also represent a Web3 data channel for transmitting this really valuable feedback data on, if you go and use one of our vouchers, we can also capture your feedback, on whether this is the sort of thing that you like, and that's super valuable as well. So yeah, with comparison to previous Web 2 platforms, the benefits of Boson Protocol are lower costs. I mean, our protocol is minimally extractive. It doesn't mean it doesn't capture value when you've got a protocol that is used ubiquitously. It can still capture lots of value, but it's minimally extractive in terms of what it takes from each transaction. You've got expanded choice because you've got market-chosen suppliers and market-chosen buyers, rather than a restricted set by a single intermediary. You've got zero reconciliation because you've actually got integrated settlement. When you do the transaction to go and receive the actual item, well, it's the same transaction that is going to be settling the amount. So all of that goes away, and you've got a single ledger for that. Yeah, I mean, the transactions are reliable, is what we call kind of practical atomicity. Also, no human intervention, so that our transactions generally do not require any intervention and arbitration. We may have an escalation path, but generally they're kind of automated transactions. And then this open market, so this property of decentralized protocols, that they can't be evil and they're resistant to capture. So all parties, all of these participants in the platform can rely that platform won't, after achieving a degree of success, then start using its market power to extract monopoly rents. So and then also a really key property for our platform over centralized platforms is that it's compatible with decentralized applications. So you would break the trust model. A decentralized app cannot plug into a centralized voucher platform or application without breaking its trust model. So really, you can see this kind of evolution of what we call vouchers, from this printed voucher token, with a simple aggregated business model, single product line, to a digital voucher token where you're running this through a centralized platform, and it was very much domain specific, to our vision of a non-fungible voucher token with a decentralized protocol. And a universal standard. And we really see this as, our vision is to become like the SMTP for representing non-monetary value. So, that's our vision. When you look at the sort of analysis of these different options, you see you've got kind of, as we've gone through, platform coordinated exchange. Whilst it was a vast improvement on analog physical business models, we're seeing all across the economy these kind of negative aspects of platforms. And then you have arbitrated protocols as well, which is one of the kind of decentralized options. However, if you, this actually experienced in real life with one of the projects I was doing, if you want to plug in a system like ours that has arbitrated transactions, it just doesn't work for your normal sort of items. The cost and friction of having arbitration sitting on top of that, plugging into a decentralized system, really kind of breaks the business model. So what our solution offers is a way to, across each of these dimensions, from price, choice, automation, a system that easily connects apps and dApps and enables digital to physical exchange. So in terms of the solution architecture, as I've mentioned, we're using non-fungible tokens to represent these vouchers. And Gregor will go into a little more what we mean by these kind of stateful NFTs. But essentially they're changing state as they flow through a closed process. And this closed process is just complex enough that it handles the necessary conditions of disputes, refunds, expiries. It's just complex enough to do that, but it's simple enough that we can manage it by a sort of kind of game mechanism. And that's an area that Dr. Zeynep is conducting academic research on. And so we have a game mechanism that ensures that there's that the outcomes are compatible with what we want, and there's no way to kind of game the system. And then finally, we incentivize data sharing, because actually a big part of our business model then is to capture this data into a Web3 data marketplace. So some of the properties of this, you can think of it as a black box. I mean, I have a tendency to think of things as black box, having done a physics degree just up the corridor there. So it's a black box that enables an app or a dApp to exchange and trade physical items with no human intervention. It's fully automated, so as I said, the refunds, complaints, expiries are handled within this mechanism, and it's reliable in terms of the transactions either happen together or not at all. So you don't have an instance where you will pay for an item and not receive it. It's that transaction happens with what we kind of call practical atomicity. So one of our advisors recently sort of tweeted this, and we're really bullish on NFTs. We see NFTs as a really fundamental building block of the digital world. They bring a kind of, object-like kind of substance to the digital world. And really, seeing these different projects like, for example, Centrifuge, which is where they have contract tokens in a financial supply chain. You also see with Boson Protocol that the data tokens flowing around a data economy. And very much see Boson Protocol as thing tokens floating, flowing around a thing economy. I won't go too deeply into this, but to say I'm not allowed to say business model in front of Zargam, it has to be design pattern, which I think is right. But essentially what we've got here is we have in the red layer that you see here is our protocol layer. So this is like the back-end system that has been open sourced into a decentralized protocol. So it's like clearing rails. And so that is, that will be eventually governed by a DAO, and there will be a Boson token there that will be kind of exchanging and regulating the flow of value. Over the top of that, the layer, we have a monetization layer. So that's a layer where we will have profit-making businesses that will operate using the layer underneath. So those businesses can do things like provide a nice user experience, abstract away the complexity of the underlying protocol, and really kind of go to whether it's suppliers, businesses, or consumers with a user experience that just feels consistent with Web 2. And having built Web 2 applications, I think, the user experience is I think the single biggest determinant of adoption. And then underneath this layer, we also then have a Web3 data marketplace. So you can kind of think of our business model as an update to Web 2, in that with Web 2 you would do something useful like search or social in order to get ubiquity. Then you would capture the data and exploit it, and put all the profits up to someone like Mark Zuckerberg. I mean, our model is similar in some ways, in that we're doing something useful. We are coordinating these transfers, but what we're then doing is also enabling optionally our participants to sell their data in a way where they retain ownership, and then with the proceeds of that sale, our token equitably distributes that between the data sharers and the token holders. And so for that we will be using the Ocean for that Web3 data marketplace, which is why it's fantastic to have Trent, their CTO and co-founder, as one of our advisors. In terms of how our kind of bootstrapping strategy, which is something I've done a bit of, what this does is, this early monetization layer will drive network effects onto the token model, and then once that token flywheel gets turning, then that will provide the incentives to share data, and then you get the third stage data model. So again, yeah, we see this as kind of one, two, three, near-term profits from centralized profit-making entities. Second stage, token model kicks in, and then third stage, long-term exponential value from a Web3 data marketplace. So in terms of kind of why now, because I think history shows that timing is everything. This is a great quote from an article, but we're really seeing now that physical assets turning into digital assets, and the ability to kind of index, search, trade, and address physical items as part of this economy of things, I think is going to be kind of one of the biggest trends, from this moment on. So we really feel we're at the dawn of that, and this is a great time to develop this product. So over to Gregor.
Hi. So how do we go about bringing off-chain items to the blockchain world? There are several ways of doing it, and let me explain why we chose what we did. So the most straightforward thing usually is you create a digital twin on blockchain. Likely you would put something like a unique chip on a physical item, which would then be represented on blockchain as an NFT or a different token. So blockchain is great for provenance tracking, and some companies are doing that really successfully. The problem is that, of course, putting chips everywhere is, first of all, expensive, and second of all, you can't put it on some things, for example, like services. You can't put a chip on that, right? Another approach is you have an oracle or other trusted or semi-trusted or there's a whole spectrum of that, an entity in between the on-chain and off-chain world, and that entity needs to be there to say, okay, this item is this on blockchain, or this item has been transferred in the physical world. That's fine for a lot of use cases, but not all. For example, proof of delivery or things like that are problematic, because you would need that the delivery guy signs a transaction and basically acts as a trusted oracle in that sense. Then there's a different approach if you are concerned about the ownership of an item. Say you can wrap the physical item in a contract, in a business document, and then you can tokenize that contract on blockchain, which is something that Centrifuge is doing really effectively. But again, there's a nice layer of abstraction, and you can do lots of things by doing that. Sometimes, but you don't want to have a contract, or you can't have a contract for every possible representation of physical item on the blockchain world. So that covers some use cases, but sometimes cannot be used. A fourth option you have is you can use prediction markets to have people or community participate in deciding what's happened in the physical world or predict what will happen, and bring this notion to the blockchain. Again, that would be a very ambitious thing to achieve for every physical item to be represented as a bet on blockchain. So what we use are actually promises of delivery, and the promise is a willingness of one person to deliver or implement something in the future in a time delay, and you can tokenize that promise and work with that. Note that here we are not working on the notion of ownership at all. It is just a claim that you have a right to a certain thing. Can I click through? Okay, so how do we get from a promise to stuff? We say that promise is a tuple of an issuer, so the person that is offering something, and underlying asset, which is either a good or service or what have you. And that asset has a value. It can be monetary value, or it can be deemed as an exchange or different kinds of values. It can be used repeatedly. It can be one-off. You might need to have more than one, and so on. And then there are conditions of how you actually can use this promise. For example, you might have restrictions on the jurisdiction. You might have restrictions on the consumers, or even basic restrictions on validity period of that promise. So a promise becomes a voucher when it is made by when it is transferred to a holder. So when I have a voucher, I know who issued it, what I can do with it, and I know that I'm the owner of it. I hold that voucher. And basically the token is then a unique digital instance of that voucher. So once we have a tokenized promise of a physical thing, we can have it. We need to follow it through its whole life cycle, right? The promise is made, it is offered, then the consumer buys it, he can transfer it or he can trade it, he can put this promise maybe into DeFi products or whatnot. It's completely under the control of the holder of that promise. But what is actually more interesting is that our voucher travels through a closed loop of certain states. The most important one is you want to redeem that voucher for the promised item. But you can do also other things, like you can refund it, you can complain about the service, etc. But this is just adding more business or real-life scenario to it. But in essence, you have a promise, which is a claim on that physical asset. It is not the ownership. And here, as Justin mentioned, we are not using any central parties or arbitrators or any entity that would adjudicate either the quality or the the disputes that happen here. We have a mechanism in play that guarantees that this travels automatically. So our vouchers are represented as NFTs, and I'm sure you all know 721, which is the father of non-fungible tokens. It is a singleton token unit, so this means that it is indivisible. There's only one, but there's also just one quantity of it. Well, we're leveraging ERC 1155 a lot. This is a proper token factory. In it, you can create fungible tokens, you can create non-fungible tokens. Actually, that's the whole aspect of ERC 721 lives just as a token type in 1155, which is great for us because what we offer is potential quantity of supply. We can't represent ticket seats as NFTs because you would have to mint thousands of them, right? What we do is you can say, okay, this is ERC 1155, which represents theater seats today, here, and there's an amount of them. And what we then do is, once a buyer purchases this voucher, we extract 721 out of it, which means that we decrease the supply in 1155, and then we can assign an actual seat number to the final NFT that the user gets. So what we do is we have a common factory that creates these tokens, which supports two standards, which means that this is quite a long code. But there are some overlapping things that we can use from both standards. For example, you can have token approvals managed by a single mapping. There's also one thing that all tokens have in common. This is metadata, so you have rich description about what the promise is about. You have pictures, you have descriptions, titles, and so on. And then there's a problem how you represent that, how you store that, and how users access it. The decentralized storage is commonly used, but there are some projects now that have admitted that it is quite a friction of using that. There's time delay. You might not get that data being available because the ecosystem is not there yet. So people start putting metadata of tokens in a centralized storage. And the problem there is that you can modify it. So this is ERC 2477 is an emerging standard that will be finalized probably very soon. And this standard is dealing about how you can guarantee the integrity of metadata, which is really cool because then you can be sure that what you have, the description of the item, of the physical item, is really what you are seeing because it matches the hash. And both these standards are, the ERC 721 and 1155 are already final. Yeah, so then there's a commercially really attractive thing are bundles, how you can create packages of different physical items, and you can do that. So the challenge here is not just to create a package and transfer it as a whole. The challenge then is also you want to redeem it. Let's say I want to come to the cinema, I want to have this seat, and I want to have a bottle of water with it. I want to buy it as a package, and I want to use it as a package. Maybe I want to then issue a complaint just for one item of this bundle. So that's a challenge here. ERC 1155 handles bundles natively because it supports batches, batch transactions, batch minting, etc. So you can do these things really nicely. But whatever you do as a bundle with 1155 really leaves can't be enforced on chain because you would then need to create that bundle on the blockchain. Instead, if you're going with 1155 to use for bundles, I would propose that the upper layer applications bundle these things together and just send them as such. So it can't be enforced on chain. On the other hand, there is ERC 998, which is called composable, non-fungible token standard, and that standard deals exactly with bundles. So you can create hierarchies of items, and you can work with them. This standard is currently still in draft. The 1155 factory is not yet supported. It adds a little bit of more code to all this, but it enables you to deal with bundles on chain as a one token which is composed of others. So we are currently on the beginning of our journey. Just to mention that we just completed Accelerator. So we have a prototype built. But we are forward looking to the next challenges that we'll have. So scalability being the first one, traditional systems process in rounds of hundreds of millions of vouchers per year. So that's a longer term challenge. And there are ways how you can achieve that, right? Luckily, we are still at the beginning, so we can postpone this decision as far as possible. But there are two approaches how we can go about it. So one is how we can organize internally. So maybe we don't mint vouchers as standard NFT in advance and for all cases. Maybe we mint NFT only on demand. So when do you really need an NFT to be standard compliant? It is when you want to transfer it to wallets that support it. That's the purpose of standards, right? And the other thing is you want to put a token in a DeFi space. You want to do some secondary stuff, some secondary uses of it, right? So this is where standards come handy. But if we could just skip this part of minting an NFT, we could create vouchers that are create tokens that are effectively optimized for vouchers. On the other hand, there are lots of cool things happening in Ethereum. I don't know which one is your favorite, but I'm really fond of rollups. So this is a scalability solution on level 2 for Ethereum, but could work, the principles hold for other blockchains as well. So the idea is that you do computation of the chain and provide proofs and data, just enough data on the blockchain that you can be sure that the computation was done correctly. There are two options with rollups in general. There are more, but two are most distinct. One is optimistic rollups, which you hope that the transactions that you put on blockchain, the whole package of it is honest, and if not, you have a challenge period to dispute it. And this challenge period is what is an issue for us, I think, because when you deal with physical items, you get a bottle of water and you have it. It would be a mess if then the transaction would be rolled up, right? Because you maybe drank your water. So the other option with rollups are ZK rollups, which is a really fascinating thing. There's a lot of stuff going on here. I won't bother you with it now. But the idea is that whatever happens off-chain, you actually can prove that it really did happen. There's a proof sitting on the main blockchain. The contract on main blockchain guarantees that what happened off-chain was really performed. Yeah, so there's other options. Some guys are really happy with Polkadot substrate and so on in Cosmos. Yeah, we'll see. And the final challenge for us is privacy, of course. So in general, the privacy issue is you want to hide transaction amounts, but there's also participants that want to be anonymous on the network. So for example, a large corporate might not want to reveal its business partners. There's another thing that's important for privacy. It's the openness or the availability of the underlying asset that you are providing. So an asset for Ocean Protocol are, for example, data sets. And if you would expose them publicly, they would lose its value and perhaps even its usefulness. And for Centrifuge, dealing with business documents, well, these are by nature private, right? But in Boson Protocol, you are buying a physical item, you want to buy it, and it's on the marketplace. It's in the seller's interest that people know about it. So the asset itself is not such a concern to be private here, at least not in the beginning. So at the moment, we have our mechanism on Ethereum. So as long as we're there, we can use, for example, Aztec to hide transaction amounts. Then people can use Enigma. I think they're close to production to do off-chain computation. There is Keep is building private storage. But as mentioned, if we are going with ZK rollups, the privacy is a big issue because it adds lots of complexity. I'm a fan of MetaLabs and their ZK Sync network, and they're working on privacy solutions. But it's really, if zero knowledge is moon map, I think the privacy guaranteeing rollups are conveniently called Bose-Einstein condensate, which is something similarly named to our boson, but not related to us. So Substrate has better privacy out of the box. They use parity secret store, but then you are basically limiting yourself to their nodes. And Cosmos, I don't know if they are working on privacy yet, but since it is an EVM, you can use their EVM stuff as well. Yeah, we have some slides ready for what we have built as a prototype, but maybe for later, or if anybody is interested in that. Thank you.
So we have a little bit of time now for questions and answers. We'll be going all to the pub afterwards, so feel free to save questions for them as well. I'm not sure if the other teams are going, but it'd be great if as many people as possible. Let's start with
you said that you were going to create NFTs based on demand. Is there any reason why you didn't consider, or maybe you did, choosing a particular sector and think to tokenize first, based on priority plus and all the things you've seen prior in the industry?
Yeah, we do have a go-to-market, and we have deliberately excluded details of that.
Understood.
Yeah, we have a pretty focused and specific go-to-market. Yeah.
Understand?
next question.
Right. Thanks for the presentation. I got two questions. First of all, can you tokenize art? And fix it in stablecoin and back on demand? And the second question is, can you tokenize intellectual property and have a similar function to a patent? Thanks.
Was the first question about art?
Yeah, can you tokenize it,
Yeah.
get it into stable, and back on demand?
So what we would tokenize with an art example is purchase of an art piece, right? You understand?
I understand.
Yeah. So our promises are not transfer of ownership. That's not the case. That would mean a lot of legal consequences, etc. What we can tokenize is the promise that I will deliver an art piece to you, and you have a certain benefits of using our system, because you can be sure that it will be delivered, and if it is in poor quality, you can do stuff. And that's what we're solving.
So it's public relation and the mediary. So you deal with public relation directly and act as a mediary. Is that correct?
Us, not as an us, but as in a smart contract.
Okay.
Yeah, I mean, but perhaps I can cover that one off. What we tokenize is the promise and realization of an exchange. So we're taking on-chain commitments to perform an off-chain exchange. Yeah, I think your question was pretty specific on can you tokenize art into a stablecoin back, right? Which it's a good question, but not one that we've thought deeply about, and if that's not one we address.
Any other questions?
I think art piece is great for provenance tracking. You put a chip on it, embed it, so it's tamper-proof, and then basically you have tokenized art.
Until the provenance is changed. Like, let's say,
Well,
art piece.
yeah, that's a problem with these
You end
things.
up finding out it's a fake.
Yeah.
Yeah.
That's right.
Yeah. So different use cases, different approaches. Yeah.
I think I watched one of your videos, and I think during one of the previous presentations you mentioned that you'll be taking deposits by both the parties. Would this be stored and locked up in a smart contract, or are you actually taking the crypto yourselves and potentially holding it in custody until the completion of the contract, or is that all locked inside a smart contract?
Yeah, I mean, it's all locked in a smart contract.
Right, so you're not actually have a possession of the...
No, it's not custodial in that regard.
Okay, cool.
Any other questions?
Right.
Okay. All right. Right. You can give them a round of applause.